Now, networking is a big topic in and of itself, and so there's no humanly way possible I'd be able to teach you everything there is to know about networking, and I don't plan to. What I plan to do is give you guys the most essential and necessary information about networking, and then you guys can take that if you want and further develop it. But this should be a starting point for you. It should help you understand what's actually happening on a network and even what a network is. So for people new to I guess computers and technology, and maybe not new, but maybe you've used the internet before and you just haven't thought about what's actually happening. And that's how I was for a long time. Actually, I had worked with an internet service provider, and before I worked there, I just thought the internet was magic. That I open up a web browser and type in a series of letters and separated by a few dots, and that somehow magically, I didn't really care how it happened at that point, it went out and found a page and magically brought it to my computer. And so if that's the kind of understanding you guys have at this point, this is going to be some really great information for you guys to take and really absorb. In this video, we're not going to be doing anything. We're not going to be learning about networking specifically on Linux. We need to understand a few general concepts before we get to that. And so this video is going to be a sort of introduction to networking on Linux and an introduction to networking in general. So right now, you are on a computerized device watching this video, which is on the internet. And the way that's happening is basically you're connected to a router or a modem router all-in-one device, and the router is connected to your internet service provider, and your internet service provider has devices that are connected to the bigger world of the internet. So you send a request. If you open up a browser and type in google.com and then hit enter, your web browser sends that as a request. It's basically saying, okay, this is the web page that this computer wants to look at right now. It sends that through your router, which sends it to your internet service provider, and your internet service provider has all these fancy computers that properly route certain requests to DNS servers, any request actually. And what a DNS server does is it says, okay, you gave me this string of text, a domain name or a URL, and I have a record here that shows this domain or string of text is supposed to serve up the content at this IP address. And so how the internet works is it doesn't understand google.com or facebook.com. The internet uses network addresses, right? And so think of it like each web server, each server out there has an address, just like every house on your street has an address. So if you were going to send somebody down the street to Joe's place, you would say, okay, well, go to this address. Then you would give them the address of Joe's place, and they would be able to find it. Right? The same thing is happening on a DNS server. You give the DNS server a domain name that you want to look at, and then the DNS server takes that and says, okay, well, I know this domain name is supposed to route to this IP address, so you request, you need to go over to this server to get that content. And so your request then gets translated to an IP address and other information, and it gets sent to the web server that it's supposed to be at. And then the web server running Apache or anything really, Nginx, or I'm sure there's tons out there that I don't know about, but the web server receives your request. It receives all of the information related to it, so cookies, session variables, stuff like that, as well as the exact item you want to look at. So if you go to website.com/something/something else, everything after the .com/ is called a URI, and that indicates what piece of content on the server you want. So think of the first part, domain.com, as what server you need to be communicating with. And then afterwards, /about.php or something. That's going to tell the server, once it gets the request, what page it needs to send you. And then it does its, rendering process, and it sends you that page in the exact same route that your request took to get there. So it's like when you send your friend down the street to Joe's place to pick up a box of pizza, and so your friend walks down the street, he turns left, maybe he turns right, he gets to Joe's place, he walks in, says, hey, I need to get a pizza. Joe gives him the pizza, and then he walks the same way back to your house, and before you know it, a web page has loaded within your computer box. And that's how that happens. I hope you guys understood that. In the next video, we're actually going to cover a few more concepts before we can dive into, really understanding to the point that we can use applications to do certain things in regards to networking. So I hope you guys found that informative. If you didn't, if there's any point in this video that you felt lost or confused, or even that I was just rambling, or even if you just want to tell me, a few more web server applications aside from Apache, there is a comment section to the side of this video, and you just leave a comment. I will reply. I'll get you whatever information you need, and hopefully this will make sense to you. So in the last video, we described how the internet works. What the internet is technically an interconnected collection of networks. So all these little networks all over the world can now be connected to other networks in the world. And so we have the internet, which is just that. So to understand a network, and here we're bringing it down from the top level stuff down to a more localized thing. And so a local network is the type of network that you have set up in your house, where you connect to the router. The router then can interact with the internet for you and then return the information to your computer. Now, I wanted to talk for a moment about IP addresses and the current issues that face them while still using IPv4. So let's go ahead and open up a document here. So an IP address looks like this. This is an IP address of a server somewhere, probably. If you put this in your... Let's actually try that. That was just a random one that I just wrote up. See what happens. This is probably the address of somebody. Somebody is connected to an internet service provider, and they get one IP address for all their computers. And the reason why that happens is because these IP addresses can go from 1.1.1.1 all the way to 255, like that. So as you can imagine, the range here is pretty big, but it's not quite big enough for the human population. And so we've been running out of IP addresses for the last 15 or 20 years. And multiple solutions have been brought into the equation to try and solve this problem. One of them was called a NAT. And what this is a network address. Basically, you have one router, you have one IP address. So the IP address you have, let's say, is this one up here at the top. This is your IP address that the internet service provider has given you. Without the use of a router, you can plug one device into the modem, and your computer will use this IP address in requests. So basically, when you send a request to google.com to load a page or to load a search, what happens is your IP address gets sent to Google as well, so that Google can return this data to your device. But what happens when you only have one IP address and 7 computers connected? That's when the NAT comes into place. So this IP address now is the IP address of your modem or router, and it assigns NAT addresses to all the devices on your network. So let's say you just have 2 devices on the network. The first one, actually the IP address of your actual router is likely this. I've seen one instance where a network did not use this IP address as its router's IP address. Okay. The IP addresses that your router will assign to computers in your home all begin with 192. So basically, it would be something like that, right? That would be the IP address. Actually, hold up a sec. I got this wrong. This is the IP address of your router. This is the IP address of your first computer. So it always begins with 192.168. Your second computer might be this. And your third computer might be this. So now you have 3 IP addresses, 3 devices on your network, and your router here is keeping track of them. So from this device, I type google.com into the address bar. What happens is this IP address, along with the request, gets sent to my router. The router then sends the request off to the ISP and then over to the internet and stuff with the IP address of the router, which internally is this, and externally this is our ISP IP address they gave us. So what happens, this gets sent to google.com. Google.com sends the page back to this IP address connected to the router here. The router then takes that request and connects it with the device that requested it, and then it sends it back to that device, right? And so that's how a router interfaces between a local network and the internet. So in the olden days, before the NAT address and routers really took off, each one of these computers would have had a different IP address. So it would have looked something like this. Right, and so on. So that would have been 3 actual IP addresses when we found a way that you actually only need 1 IP address per network. And so that's what a router does. And so these IP addresses are local, and you're going to see these in terminal. Now, one other special IP address is 127.0.0.1. On every computer, this means this computer. It's basically a self-identifying IP address. If I were to type this into my browser, I would see my local host, where if you put this into your browser, you would see your local host. 192.1, the NAT IP address basically works the same way. So if I were to go to 192.168.0.3, it would try to find a computer only on my network that has this address and then connect to it. So that's how a router works. And in the next video, we're going to be getting into the ifconfig. On Windows, you have an ipconfig command. On Linux here, you've got ifconfig, and we're going to cover that in the next video and a few other commands as well. So thank you guys so much for watching, and I'll see you guys soon. Hey guys, welcome back. In this video, we are going to get to some practical networking things, and this is all in Terminal. And so the first thing we're going to do is bring up Terminal. And first I want to talk about the ping command
and what this means and what it does. So you can ping an IP address or a domain name to see if you can get a successful response from it. This is a great way, let's say you're using a web, this is just an example, if you're using a web browser and you're trying to troubleshoot if the web browser isn't working or if your entire internet connection isn't working, you might drop down here to command line and run a ping command on a known host that you know is always going to be up, for instance, google.com. And so that's exactly what we're going to do. So I'm just going to type in the command ping and then the address of what I want to ping. And I'm getting a response, and it tells us what length of time each response is taking to return to us. So yeah, I mean it also shows other stuff like the exact IP address, the server that it's reaching, and that good stuff. And this is going to just go until you close it, so just Control C to exit, and then it gives you a breakdown of what happens. So you could let this run for a while to see if you're getting any packet loss through your network card. And so that's what pinging does. So I'm going to clear this up here. We're going to talk about the command ifconfig. So on Windows, in command line, you have a command called ipconfig, and it spits out a whole bunch of information about your network configuration. In Linux, it's ifconfig, and it does the same thing. So I'm just going to make this a bit bigger here, and I'm going to run that command again. All right. So this is going to link our addresses here, or our network interfaces, and also any IP addresses that it has and whatnot. So the first one is going to be an Ethernet, which I don't have plugged in right now, and so it's going to be basically not working. This is the name of that interface. This is our local loopback. So this is like a virtual interface that runs that it has our local host address here, and it basically controls that. And then down here we have our wireless Ethernet, which we can see this is working as I've got received bytes. So RX basically means what you've received. TX basically means what you've transferred out. So that's how to read that. There's an IP6 address right here. And my IP address, or this is going to be my NAT address, and it gives IDs and stuff of the network interface device. And so that's basically how to use ifconfig. Sometimes this might be useful to see if you're getting a valid IP address from the router, and to see if it's actually working at all, which you can see here mine is. So I'm going to clear this. And what we're going to go over now is a command called TCP dump. It's a really powerful command line packet sniffer. So it can analyze the packets that are going in and out of your computer or your network. So first thing we need to do is install it if we don't already have it installed. So sudo apt-get install TCP dump. It's probably already installed, but just in case, I'm going to make sure. And it is, and it's the newest version. So this is a big command line tool, and I was going to do more stuff in the video, but I think we're going to cut it off after this command. So what we're going to do is basically just run the command TCP dump. We don't have permission to capture on that device, so we're going to run sudo TCP dump. And this is capturing all packets that are coming in and out of my my computer, and this is just going to run until you cancel. So I'm just going to cancel here. Now, as you can see, that was a pretty big output. And so what we can do is we can only capture a certain amount. So what we're going to do is that. So how we do that is basically using the TCP dump command with a C. Let's capture 10, and that's good. All right, I've got to run it as sudo TCP dump -c 10. So this is going to capture 10 packets, and that's all it's going to do. Right now it's not capturing any. Let's go ahead and do some updates. So that just captured 10 of the packets from my machine that was essentially coming into my machine. And so we can analyze them a bit. We can see where they're going to and where they're coming from. And so we can see here basically, so the first column is a timestamp, right? Over here we've got the IP address that we're sending from. So this is our machine here, as you recall, and it's sending this packet out to our router, which basically ends up here at this domain. And so that's how to use TCP dump very, very minimally. There are some other options that we can go through as well for this command. So you can print the captured packets in ASCII. So let's go ahead and do that. TCP dump. I'm gonna run C10. We're just gonna capture. Let's capture 5. And then we run -A. And this is going to print out the actual packets in ASCII. So you can use this if you're trying to see, what exactly you're getting. And this just all looks like gibberish to me, but it's the packets that are actually coming through. So that's a neat way to use this command. So basically, if you only want to listen on one network interface, I'm going to run ifconfig again. And we can see WLO1 is the name of this device. So what I'm going to do is run TCP dump as sudo. I'm going to capture 5. And we're going to use -I WLO1. And what that -I does is it tells it to listen to a very specific interface that we define after that -I. Now, in addition to displaying the packets in ASCII format, we can also display them in hex and ASCII. So this may make sense for you if you're looking for some hex response from these packets that are coming in and out. So what we're going to do is run sudo TCP dump -XX -I WLO1. And this is going to print out, I didn't use the C flag, so I'm just going to cancel there. So this is going to print out packets in hex and ASCII format. So I'm going to clear this here. One other neat thing is you can capture packets from specific ports. And so let's go ahead and do that. So let's run sudo TCP dump, and I'm going to show you guys why that's going to make sense here in a moment. -I WLO1, this is the name of my interface, and then port 22. Now, right now, I don't think I have any port 22s going on here, and that's because port 22 is an SSH port. So what I'm going to do is I'm going to connect to my server via SSH, and we're going to see packet activity here. So I'm just going to connect, and here we see a bunch of packets happening. And each time you do something, you can see exactly what's happening here, and you'd be able to parse through these and basically see that there is activity, what kind of activity, and where it's happening between. So So that is a bit about the TCP dump command. This is going to be good with troubleshooting network activity. There's not really many other uses that I can think for this, but if you have any uses for this that I don't know about, leave a comment. I would like to know how you guys use this command if you do, or any practical applications that you think this command would serve. Hey guys, welcome back. So last video we looked at a way to really track packets and the packets that are actually being sent to and from this machine individually as packets, and now we're going to talk about a command called netstat, which is an abbreviated term for network statistics. So basically the command that we're going to be using throughout this video is netstat, and based on the flags that we pass it, it's going to return different statistics. So if I put netstat-nr, the n option makes netstat print addresses as dots, dotted IP addresses rather than symbolic host to network names. So this is going to make sense if you want to see the actual IP addresses rather than the domains that are connected to the machine. And so this is what I've got right now. It basically gives us the information that we're looking for regarding the IP routing table. And so the R flag in that command that I just put basically states that we're looking for the kernel IP routing table. And that basically shows what certain things are routed to. So let's actually display network interface statistics themselves. And we're going to do that with the -i command. So we're going to type netstat-i. And this shows us the usage of each of our devices. And so we can see the local host here, which was configured, has sent this many packets right here. And it's received this many packets. As compared to our wireless interface, which so far has received that many, and actually this is bytes, not packets, and this many. So you can kind of see how this would be useful. We can actually display connections to our machine as well. And so I think my system updater is still going. It is. So this is going to be good. What we're going to do is run the netstat with the flags -ta. And this is going to look for active sockets, and it's going to print out the status of them, and basically, the foreign address and the local address. So this obviously is our local machine here. These are the foreign addresses that it's connecting to. And so what I'm going to do is I'm going to run netstat-tan, and it's going to show IP addresses instead of the host names. And so you can see how that's going to be useful because we can actually combine elements of the different flags that we're passing to the netstat command, and it's basically going to change the way that each of these outputs works. And so that is how you would use netstat to view active connections and active routes of IP addresses internally through the command line here. And if you're not sure of if you think your computer may be connecting to a malicious host or something, what you can do is you can take these IP addresses and you can actually look them up through a website like network-tools. I think it's network-tools.com. It could be .org. I'm not sure. But you can find information about each one of these hosts if you're not sure where it came from. And just by looking at these, you might be able to, the actual host names themselves, you may know what they are. I think these are all my updates that are happening through the software updater, so that's I don't recognize any of these. So that's how to use Netstat. I hope you guys enjoyed this video and found it informative. I hope you guys can basically understand what Netstat does. It's a very simple command, but it's very useful in a lot of circumstances. So thank you guys for watching this video. I'll see you guys soon. Hey guys, in this video we're going to talk about hosts briefly. So in terms of our local host actually. So there's two parts to this video. The first we're going to cover is the hosts file, and we briefly touched on that in a previous video. I think when we were deploying I think our Meteor application with Apache 2, we went into our hosts file to create some routes for the application. So basically the hosts file is in etc/hosts. So we can go ahead and open that up. Just type sudo nano /etc/hosts and hit enter. Put in your password. And this is our hosts file. So we actually did, we were in here for app.localhost, subdomain in Python. So the virtual hosts and Python deployment and the Meteor deployment, we were in here. And I didn't really explain to what extent you can use this file. So as I explained in the networking introduction video, a DNS server basically holds records of what domains point to what IP addresses. Think of this file as an internal DNS lookup functionality. So when I go to app.localhost, the first place my computer checks for a route is the hosts file. If it doesn't find an entry for a domain in the hosts file, then it goes out to the router and then your ISP and then a DNS server, and it checks there if there's any records for it. So by adding entries here, we can actually override default behavior of known domains that we want to change. So what I'm going to do is open up Firefox here for a moment, and I'm going to go to a website that will allow us to get the IP address of google.com, because we're going to be using that. So I'm just going to go to network-tools.com, and I'm going to type in here google.com. And we can see that this IP address is the one we are looking for. So I'm going to copy this here, and I'm going to jump back into this file. Now, this file can take 3 columns, and we've only discussed 2 so far. So let's go ahead and cover all the columns here in great detail. So the first one is the IP address that we want to route to. The second column is going to be the domain or the host name that we want to route to that. So let's just type in go.com. And then the third column is an alias, so we can just type go. And so when we save this file, what we're going to see is when we go to go, it's going to go to google.com, and their servers have actually they're not okay, so they're doing a lot of internal routing there. Let's try YouTube. So what we're going to do, again, we're going to get actually let's try something that we know is going to work. So I'm going to just type in my own server name here. I'm going to grab that IP address, jump back into our hosts file, and I'm going to paste that there. Now I'm going to save this again and go to go.com, saying it's not found. Weird, because this just worked. Alright, so I just had to restart Firefox here. This is the default server page, the root page for my server. If I were going to server.pointybracket.net, and I actually get the exact same page. And so what I can do, I believe, is access the routes on the server as normal, and it works. So what we're doing, as you can see, is we're just setting DNS records internally for this machine that it looks at before it goes out to get the correct DNS information. So again, I'm going to go to network-tools. We're going to try with let's try and find Joe's Pizza, a website for them. There we go. So let's see if this will work. This is the IP address I'm getting. So I'm going to check if that IP address will route to the website as well. No, but it routes to this page. So this is the page we should see after we paste this into our hosts file. So let's go ahead and save. And then let's go to go / no, let's close this. And there we go. And so you can see how this works is basically it routes to whatever we want to route to. So you could create shortcuts for your favorite websites, with the exception of Google. Google does a lot of internal routing and stuff. And sometimes this will work, sometimes it won't. It all depends on how the web server is set up. Usually though, I just use the hosts file to set domains to go to my local host, and that's for when I'm developing something that a URL needs to be set with. So if I'm developing a WordPress site on my local machine and I need to set a URL in the WordPress configuration, I would configure a domain and then point that to my local host. So that is the hosts file. Let's exit out of here and close this. I'm going to clear that. So now our host name. A host name is basically a name of machine, and in this instance ours is called Voltron, and we can see that because we've got this right here. So you can use the host name much like the same way you can use custom hosts that you set. So I can just go to Voltron and it's going to route to my Apache default page. Now you can also update the host name, and we need to do a couple things in order to do that. So first we're going to run the command sudo hostnamectl set - host name, and then whatever host we want to name it to. So Megazord. Now we need to edit the hosts file to update our host name here as well. So we're going to replace Voltron with Megazord. We're going to save this and close it. And then we're going to run sudo service hostname restart. There. It said it failed to restart the hostname service, but it looks like its working hostname is now set to Megazord. And if I were to close the browser and reopen it, I should be able to go to Megazord / and it does in fact redirect me to my default Apache 2 page. And so that's what a host name is and how to change it on Ubuntu. You could also change it through the system settings, but we're not going to go through a GUI way to do this right now. So thanks for watching. I hope you guys found this informative. If you have any questions, just leave a comment. Otherwise, I'll see you guys soon. Hey guys, we're about to talk about the traceroute command and what it does and why you'd use it. But first we need to install that program. So just come along with me, run sudo apt-get install traceroute, and it's going to fetch that from the repositories, and it's going to install it for us. And when it's done, we can run the command. So run traceroute, all one word, and then the domain that you want to trace the route to. And it's going to spit out every server that the request jumps from and to in order to get to Google's server. When you see 3 asterisks, it means the request has timed out on that server, so it's going to try another one. There we go. So let me make this a bit bigger so it might be easier to read here. All right. So we can basically trace what servers we are communicating with in order to get to google.com. So when I type in google.com into my browser, it doesn't just go from my router. The request doesn't get sent automatically right to Google servers. What happens is there's a lot of intermediary servers in between the two, including your ISP, the DNS servers, and then other servers that need to be hopped to in order to get to Google. And so this is what we're seeing here. The first request, this is the IP address of my router, and this is the length of time that it took to get there. What happens then is this address is where this goes, and you can see each address as we go down gets a bit different because we're going to a different part of the world, and the host name will show if it's available too with the IP address in brackets, so we can see this is my ISP, and this is one of their servers that my request has to hop from in order to get the information required to get to google.com. So I'm going to try with my own server here. So I'm just going to type traceroute pointybracket.net. And we can see that it's accessing different servers in order to get to where it needs to be. So in here we can see 2 interesting things. First of all, my internet service provider, and second of all, my virtual private server provider. And I'm not going to point those out, but we can see that, and then we can see also everything in between that holds information about the route that our request needs to take in order to get to that server. So that's how to use traceroute, and that's why you would, is just kind of to, trace the route of your request to different servers. So thank you guys for watching this video, and I will see you guys again soon. Hey guys, welcome back. This is the last video in the networking module. I just want to give you guys the tools you need to further your knowledge of networking in general and how networking tasks would be performed on Linux. And so there is one more tool that I want to introduce you guys to called Nmap. So Nmap is an abbreviation for the term network mapper, and it's an open source tool that can tell you what devices are on the network, what IP addresses are in use, and what services each machine is offering. So let's go ahead. We need to install the tool. So let's run sudo apt-get install nmap. And it's going to download about 3 megabytes of data, and it's going to expand to 18 megabytes. All right, now that this is installed, the way we're going to use this is by simply typing nmap, and then we can do a bunch of things after this. So the first thing we're going to cover is how to scan a specific IP address. And so I want to get the IP address that I have, so I'm going to run ifconfig, and it's 0.100. So nmap 192.168.0.100. And we can see what ports are open. Well, we can see what ports are available, their state, and then also the service that they provide by name. So I have Apache installed on this machine. You guys should have it installed on yours as well if you went through the Apache videos. And so you should see the same thing here. And so the port is 80. The state is opened because we've got Apache running right now. It automatically runs when you start up the machine, and the service that that port provides is HTTP. So if I were also running an SSH server on this machine, you would see another entry in this list for port 22. It would say state open and service SSH or something to that effect. Now if we want more information, we can run nmap-v and then the IP address again. So 168.0.100. -v means verbose, and what verbose mode does in most applications is it also, aside from the regular output, it also gives you more direction on what's happening in the application, or provides more information than you would normally get. And so in this instance, we see that it's doing a bunch of scans. It scans the IP address then for 1,000 ports, and it finds all these ports that are open, and then it also finds a bunch of closed ports listed here, 996 closed ports, and it gives us the same output as before. So that's neat. I only have one device on my network actually, except for my router. Now my router, I believe, is 192.168.0.1, or it's .2.1. No, it's .0.1. All right. So that is the IP address of my router. So what we can do is we can scan multiple IP addresses at a time in multiple ways. So the first way that we're going to do is by specifying each IP address. So let's go ahead and run nmap 192.168.0 dot, and then we're going to add the last values in here separated by comma. So first I'm going to scan my machine as well as the router, and if I had a network address of 192.168.0.10, I could also do that, but I don't, so I'm not going to. Now what we see here is this right here would be my router. We can see this is the IP address for it, and this is what ports that it offers on which, or this is what services it offers on which ports, and then we get my machine right here that provides the same output as it does before, but this is how it would output multiple machines scan results. Now you can also scan a range of IP addresses. So let's go ahead and run the nmap command again at 192.168.0.1-100. This is going to go from 1 all the way to 100, and it's going to scan all IP addresses within that range. So if I had a bunch of machines on my network, which I actually do, I have my phone on that network as well, and that's it actually. So I've got my router, my computer, and my phone. My phone is not it's not coming up, so I'm just I'm not doing anything on my computer right at the moment. I'm just checking what IP address I have on my phone here, if I can find out how. Okay, so the IP address on my phone is .101. So what I'm going to do is run the previous command and just have it scan from 1 to 101. We should see 3 machines come up. I don't think my phone has any services or open ports that it would list, but let's have a look here. And when you scan multiple IP addresses, the more you scan, the longer it takes. So, no, okay, so there's nothing available for my phone coming up. Now you can also scan, so when we talked about IP addresses, whoa, 192.168.0. We discovered that you can use anything from 0 to 255. So if I were to want to scan all IP addresses that begin with 192.168.0, I could then put this in here, right? But rather than doing that, we can actually use a wildcard here. And I'm actually going to cancel out of this because it's going to take a while. So now you don't only have to scan devices on your local network, you can also scan external IP addresses or host names. So I'm going to scan my server here by typing nmap and then the host name of my server. It's going to take a moment, and I've got like a lot of open ports just because I have so many different things running. I've got there's a lot of things that run on it, and some things that I just set up that I've never really used and I haven't bothered to shut them down. And so what we get here is my host, and we can see that I've got FTP, SSH, SMTP, we've got the standard domain and HTTP, POP3. There's a bunch of stuff here, and I'm not going to go into what all those are, but we can see that these are everything that the server has. Now you can also set a file. So let me clear this. Let's open up gedit. So we're going to create a file of hosts that we want to regularly scan, and this can save time when we scan them. If you've got like a few hosts that you regularly check on. So I'm going to put pointy bracket .net 192.168.0.1 and 192.168.0.100, and then I'm going to save this as networks.txt. So what we can do there is we can type nmap-il, so it's a lowercase I and a capital L, and then the location of that file. So it was networks.txt in my home directory. And it's going to scan each of the hosts that is in that networks file. And it returns in the order that they were scanned in. So that's pretty neat. I want to go over a few more things with you guys regarding this command. It does get pretty big. There's so much stuff that you can do with this, and so I really urge you guys to go and explore this if networking is one of your interests, if you want to really follow that. One of the things that I want to show you guys is how we can turn on OS and version detection during the scan. And so what we're going to do is type nmap -A 168.0 to 100. And this is going to scan, there. I had a little typo in the IP address there, so I had to just fix that. So this should tell me the operating system and versions that are running on the devices on my network, and you can also find this information about other hosts. Aside from this, just while this is running, you can scan a network and find out which servers and devices are up and running by using the flag -lowercase s capital P. You can display the reason that a port is in a particular state by adding the flag --reason. You can choose to only show open ports, which appears to be the default functionality here. It doesn't show the closed ports. You can actually also show all of the host interfaces for a machine by typing --iflist in the list of arguments for this command. And I mean, it's really big, so go ahead and look this up. Just if you want to type in google.com nmap commands, there's a bunch of different ones that you guys should probably play around with. This was more of an introduction onto the most common or basic functionalities of this program. And actually, I'm going to cancel this here. And I'm just going to restart this so it'll go a bit faster. I'm just going to target my own IP address here so that we can get this done. And you guys can see the example output that this is going to do when adding the -a flag in here. So here you can see a lot of information about this machine. So let's go up to the top here. We've got the port, the state, and the service, as well as the version of the service. So I have Apache 2.4.12 installed, and that's also the same one here. And if we go down, we get more information about the host itself. So we have OS is Unix. We've got the computer name, the domain name, if any is configured, the fully qualified domain name, and just a lot more information. So that is the nmap command, and it would be useful if you're trying to just scan your network. One of the examples that comes off the top of my head that would be, when I would use this command is if I notice that the internet's running a bit slow. Let's say I've got 10 people in my house and half of them may or may not be using the internet, and I want to see how many people are online. This is what I would do in that instance. Or if you want to check how many machines offer a certain service, or what the IP address is that you need to use to access a certain service on another machine, this would help you figure that out. So thank you guys for watching this video. We'll see you guys again soon. Hey guys, in this video it's all about SSH. So first, what is SSH? It's an abbreviation that stands for Secure Shell, and it basically allows you to access the shell or the command line of a remote host that has an SSH server set up. And so in one of the previous videos, I connected via SSH to my own server, and so I'm going to do that again, and I'm going to explain exactly what I'm doing as I'm doing it. So the way to get connected to a remote host through command line is using the SSH command, and then the only argument it's going to take is the connection string. So in this case, it's my username on my remote host and then the remote host. So I can use this or any other domain name that points to that server, or I could use the server's IP address. And when I hit enter, it's going to ask for my password on that machine. So I'm going to put it in. And you're going to see that the prompt is going to change. I've actually got this machine named the exact same thing as I have my server name. So it's Nick at Voltron here. And I'm on my local machine. So if I were to go to var www HTML, and then run the ls command, I'm going to see that I've got a lot of directories here actually. And a lot of these are actually unused in old projects that I worked on. But anyway, basically once you get connected, all the commands are the exact same because it's essentially just a remote Linux shell. So I could return to my home directory and then list those files, and you'll see that again I've got just a bunch of random files. So that is how to connect to SSH. When you're done, just type exit and the connection will be closed. So that was a really short video. Just to recap, how to get connected is type SSH, your remote username at the name of the remote host, and hit enter, and it's going to ask for your password. So thank you guys for watching this video. In the next video, we're going to be going over some SFTP, which is a bit bigger. Hey guys, let's go over some SFTP. So first, what is SFTP? Well, first, before we answer that question, let's ask a similar but different question. What is FTP? So FTP is an acronym for the term File Transfer Protocol, and it uses the port 21, and basically what it does is it transfers files between two machines. So SFTP, because in regular FTP, everything is transferred in clear text. So if anybody's sniffing packets on your network, like we learned in a previous video, they would be able to read all those packets, basically. So we're not going to use FTP. I actually recommend never use FTP. SFTP is just easier anyway, and so we're just going to use SFTP. So similarly to the SSH command, you're going to write SFTP and then the connection string. So in my case, it's exactly the same as before. It's going to then ask for my password for the remote host, so I'm going to put that in here. And now I can list what's on the remote host by typing ls, but we also have a few different commands to list what's on the local host. I'm actually going to exit here. I'm going to make a directory called SFTP demo. I'm going to change into SFTP demo, and I'm going to touch a file called names.txt. Now I'm going to reconnect while in this directory to my server. Now if I run ls, I get the remote directory's current directory listing. If I type lls, I get the local listing of the directory that I'm in on the local host. And so here we can actually we can grab files and transfer them to and from both machines. So if I wanted to put names.txt onto the server in the current directory, what I would do is type put names.txt, and it's going to upload it to my remote host with the same name. So that's when you would use put if you want to push a file from your local machine to the remote host. Similarly, you'd use the command get to get files. So I'm going to I really don't recall any of these files. I'm just gonna get the composer JSON file. So I'm gonna type get composer.json, and if I run LLS on my local machine, I now see that I have that file there. So if I exit and then run ls, I've got that file there. So that is how you would use SFTP to transfer files to and from machines, and also a few of the commands there that can help you see what files are available. So thank you guys so much for watching, and I will see you guys again soon. So the last video that we're doing is setting up an SSH host on our local machine, and it's really simple. So let's go ahead and open up Terminal. we need to install OpenSSH server. So go ahead and run sudo apt-get install OpenSSH-server, I believe it is. We'll get an error message if that's not it. It's been a while since I did this, so. So now, once we have it installed, you're basically good to go. However, we are going to make it a little more secure. We're going to change the port that this runs on, and so there is an SSHD config file now. Let's go ahead and run sudo nano. It's in etc/ssh/sshd_config, I believe it is. There it is. So we can go ahead and make this more secure by changing the port and also changing the authentication stuff. So let's go ahead and change the port to 2212 instead of the default 22. And then we're going to scroll down here a bit. And under authentication here, we're going to change permit root login to no. So nobody's going to be able to log in as root. We're going to scroll down a bit here as well. And we're going to add a line that says allow users. And this is going to take basically a list of usernames of users who are allowed to log in through SSH. So I'm going to make my user account able to log in through SSH, and this is going to restrict all other users from connecting to this machine via SSH. So I'm going to save it and exit. I'm going to clear this a bit. And then what we need to do is restart the SSH service. So run sudo system control restart SSH. And you're good to go. And so now if I were on a different machine here, actually, let's see if I can get my external IP address here. I don't think I can get it through here. No. All right, let's clear this. I'm going to open up network-tools. I'm going to do something like if you guys have seen the movie Inception, this concept that I'm about to do will feel a little bit familiar to you. This, by the way, when you go to network-tools.com, the IP address that pops into this input field by default is your external, your public-facing IP address. This is the IP address that your internet service provider gives to you. Now, actually, in order for this to work, this would have to be the only machine, or I would have to set up through the router DMOS port forwarding or a host forwarding. But what we can try, we're going to try it anyway. I'm going to SSH into my pointy bracket server. And then from here I'm going to SSH into this machine. If it'll let me, it probably won't forward that port. So I would have to go through my router at this point to configure port forwarding for that port 2212 in order to be able to connect from an external host to this host. If you only have one machine plug, so basically, like the IP address of my server, when I go to the IP address, it goes directly to my server. It's not configured through NAT addresses. My server actually has 5 IP addresses, and those IP addresses go directly to my server, and that's why I can access SSH on that server without having to configure any routers or anything. I think actually the server provider managed that in some way. So Anyway, if I were to go into my router and configure DMOS or port forwarding, what I was just doing would in fact work. So thank you guys so much for watching, and I will see you guys again soon.